Hi everyone, today in this video I am going to prove the Leibnitz theorem by using mathematical induction. So let's get started. Leibnitz theorem. Statement. Actually this Leibniz theorem is used to find the nth derivative of product of two functions. Suppose there are two functions. If they are in the form of product, then we can find nth derivative by using Leibniz theorem. So now write down the statement. If y is equal to u into v, where u and v are functions of x having derivatives of nth order then yn is equal to n c naught un into v plus n c1 u n minus 1 v1 plus n c2 u n minus 2 v2 plus and so on plus ncr u n minus r vr plus and so on plus ncn u vn, where the suffix of u and v denote the number of times they are differentiated, and ncr denotes the number of combinations of n different things taken r at a time. So now to prove this theorem we can use the mathematical induction. We shall prove this theorem by mathematical induction. So mathematical induction means first we have to put n is equal to 1 on both the sides LHS and RHS and show that left hand side is equal to right hand side. The second case we have to assume that the result is true for n is equal to m, and the third case we have to show that the result is true for n is equal to m plus 1. So first I will write case 1. Case 1. We have to show that the result is true for n is equal to 1. So first I will take y is equal to u into v. Then what is the differentiation of this? y1 is equal to, if you differentiate with respect to x, y1 is equal to, in this case, second term v as it is. What is differentiation of this first term? Differentiation of u is equal to u1 plus. Now first term as it is, and the differentiation of this second term is v, its differentiation is v1. And the same term we can also write it as, that is 1 c naught u1 into v plus 1 c1 u into v1, because 1 c naught is equal to 1 c1 is equal to 1. So we can write it as 1 c naught u1 into v plus 1 c1 u into v, where if you see the formula, it starts with n c naught and ends with n cn. So here also it starts with 1 c naught and ends with 1 c1, means the result is true for n is equal to 1. Therefore the result is true for n is equal to 1. Now case 2. In case 2, we have to assume that the result is true for n is equal to m. Case 2. Case 2. We have to assume that the result is true for n is equal to m. Means just we have to write down this equation. We have to write down this equation, means given equation by replacing n by m, so that what we get that is ym. This n is replaced by m is equal to mc naught um into v plus mc1 u m minus 1 into v1 plus mc2 u m minus 2 v2 plus mc3 u m minus 3 v3 plus and so on, plus mc r minus 1 u m minus r plus 1 into v r minus 1 plus mc r u m minus r v r plus and so on, plus mcm u vm. So this is the second case. We have to assume that the result is true for n is equal to m, means in the given equation just n is replaced by m. Now step 3, or we can write case 3. So that is case 3. So in this case we have to show that the result is true for n is equal to m plus 1. we have to show that the result is true for n is equal to m plus 1, and for this we have to differentiate the case 2 with respect to, we have to differentiate on both the sides. So what we get, if we differentiate ym, we get y m plus 1. So I will write here, differentiating on both the sides, we have differentiate both sides. We have, okay, if you differentiate this ym left hand side, you will get y m plus 1 is equal to, next mc naught as it is, mc naught as it is. Now we have to differentiate this um into v by using product rule. So first in this case, second term I will write as it is. Second term I will write as it is. Second term is v as it is. What is differentiation of first term? First term is um. Its differentiation is um plus 1. Okay, plus. Now first term um as it is, and differentiation of second term, differentiation of v is equal to v1. This is first differentiation. Next, plus. Next term is mc1 into bracket. Now we have to differentiate the second term. We have to differentiate this second term by using product rule. So in this case also, first I will write second term as it is. What is differentiation of um minus 1? Differentiation of um minus 1 is um plus. Next um minus 1 as it is, um minus 1 as it is, and differentiation of v1 is equal to v2. Next we have to differentiate this third one, mc2 as it is. Differentiation of this um minus 2 v2 is equal to, so here I will write mc2 as it is into, now differentiation of um minus 2 v2, where I will keep second term as it is. And what is differentiation of um minus 2? Um minus 2, its differentiation is um minus 1, because you have to add plus 1. Plus, now first term um minus 2 as it is, and what is differentiation of v2? Differentiation of v2 is v3. Then plus, next mc3 as it is into bracket. What is differentiation of this um minus 3 into v3? You have to differentiate by using product rule, and here you can write v3 as it is. Differentiation of um minus 3 is um minus 2 plus um minus 3 as it is, and differentiation of v3 is equal to v4. Then plus and so on. Plus and so on, continue in the same way, plus. Now what is the differentiation of this um minus r plus 1 into v r minus 1? So in this case, mcr minus 1 write as it is, that is mcr minus 1 as it is into, now here I will write second term Vr minus 1 as it is. I will write Vr r minus 1 as it is. What is differentiation of u m minus r plus 1? Differentiation of u m minus r plus 1 is equal to u m minus r plus 2. U m minus r and plus 2 plus u m minus r and plus 1 into differentiation of v r minus 1 is equal to v r. Bracket complete. Then plus next term is mcr into bracket. In this case, you have to differentiate this u m minus r into v r. And in this case, you can write first Vr, second term Vr as it is. Differentiation of first term, differentiation of u m minus r is u m minus r plus 1 plus second term, sorry, first term u m minus r as it is. And what is differentiation of Vr? Differentiation of Vr is Vr plus 1. Okay, then continue again in the same way. Plus at last, what is differentiation of this u into vm? So I will write mcm as it is, mcm as it is into bracket, second term vm as it is. What is differentiation of u? Differentiation of u is u1 plus first term u as it is, differentiation of vm is vm plus 1. So these are the differentiation of case 2. Now y1 ym plus 1 ym plus 1 is equal to, you have to multiply this or simplify this. mc0 into this first term, mc0 into first term is, that is mc0 v u m plus 1 plus, now multiplying to the second term, mc0 into this second term, mc0 into second term is mc0 v1 plus next term multiplying with mc1 into this first term, mc1 into first term is mc1 v1 um plus, now mc1 into this second term, mc1 into this second term is equal to, that is mc1 um minus 1 v2 plus next one is similarly mc2 into this first term, mc2 into first term is, that is mc2 v2 um minus 1 plus this is mc2 into second term is equal to, that is mc2 m minus 2 and v3 plus mc3, next term I will write directly mc3 v3 um minus 2 plus mc3 um minus 3 v4 plus and so on, continuing in the same way. Then what you will get, mcr minus 1, simplify here, plus here multiply, that is this mcr minus 1 into this first term is equal to mcr C R minus 1 V R minus 1 U M minus R plus 2 plus, similarly multiplying to the second term, this second term, and you can write that is M C R minus 1 U M minus R plus 1 into VR. Okay, then plus next term is this MCR into this first term. MCR into first term is, that is MCR VR U M minus R plus 1 plus multiplying to the second term. This MCR into this second term is equal to, that is MCR U M minus R into V R plus 1, then plus and so on, again continue in the same way, plus at last if you multiply MCM into this term is equal to, that is MCM VM U1 plus MCM U VM plus 1. So this is the simplification. Now I will write the left hand side, that is Y M plus 1 is equal to. Now here this is the first term which is non-repeated. This is the first term which is non-repeated. Now here I will write first term, this is MC naught as it is, that is MC naught as it is, V U M plus 1 as it is, plus. Now you can see these two terms, which one? From this term and from this term. So here you can take this UMV1 common. Here also you can take UM and this VM. UM and V1 is common. So I will write UM into V1 which is common. So what are the remaining terms? The remaining terms are, that is into bracket MC naught plus MC1. Okay, then plus. Now from this term and this term, from these two terms you can take UM minus 1, UM minus 1 and V2, that is common. Then the remaining terms are MC1 plus MC2. Next, from these two terms, from MC2 UM minus 2 V3 and MC3 V3 UM minus 2. From these two terms I will take, that is V3 and UM minus 2 common. And here we are left with MC2 plus MC3 plus, continuing in the same way. So I will take this term and from this term. So from these two terms you can take UM m minus r and plus 1 into v are common, and then the remaining terms are mcr minus 1 plus mcr. Similarly, plus continue in the same way, and at last we are left with this term only, with last term only. We are left with this term only. So that is, last term is plus mcm u vm plus 1. In this case, I have not taken the common from this term, because this term here um minus um into u1 vm into u1 is common from this previous term. Then this is common from this is common from this is common from this somewhere here, and then this is common from your previous term, then this is common. Like that you can take the second, third, fourth, fifth, sixth, seventh, eighth, ninth, and at last in this case the first term which is non repeated and last term which is non repeated. The middle terms are repeated where you can take um v1 is common. It is not repeated, but where you can take common. And now we know that mc naught value is equal to 1. Similarly, m plus 1 c naught value is also equal to 1. mcm value is equal to 1. m plus 1 c m plus 1 value is also equal to 1. And then we know that mcr minus 1 plus mcr, and this is equal to m plus 1 cr. This is the formula. By using this formula, each bracket term can be expressed as, so I will write here, that is y m plus 1 is equal to, so what is the value of this mc naught? mc naught value is equal to 1. I will leave, so we are left with v u m plus 1 plus next term is u m v1 into bracket. Now what is the formula for mc naught plus mc1? mc naught plus mc1 is equal to this one. By using this formula, by using this bracket formula, we can write it as m plus 1 c1, m plus 1 c1, then plus next term is u m minus 1 v2 as it is into bracket. Now again by using this formula, this mc1 and mc2 we can write it as m plus 1 c2 plus next v3 u m minus 2 into, now next again this mc2 plus mc3, by using formula we can write it as m plus 1 c3 plus and so on plus u m minus r plus 1 v r into bracket. So now this is, by using the formula we can write it as m plus 1 c r. Similarly plus and so on plus last term is mcm u vm plus 1, which shows that if you compare with the second equation, the equation which is given, only in place of n we have m plus 1. Hence the result is true for n is equal to m plus 1.